Hi, I'm David with EV World News. We talk about electric vehicles, green energy, and the stock markets. And I'm here today with our resident engineer, Mike Herzog. How's it going today, Mike?
Doing pretty good, David. Good to be back in the saddle.
Yeah, yeah. Well, I was on vacation last week and I just didn't have a good place I could really do the show. Sometimes you can have a spot in a hotel or something. I was in the place I was at, it was basically like an apartment that was really poorly laid out and
Oh,
didn't have a good place I could do a show. And I was like, well, this is frustrating. But anyways, so I wanted to start out today to talk about something that we covered briefly yesterday. BYD has some new chargers that Bill branded the Ultra Supercharger. Okay. And they're a 1.36 megawatt charger deploying across China that deliver a minimum of 248 miles of range in 5 minutes. So we're talking almost a mile of charge per second. And now this all sounds well and good, right? We've looked at how, like the Tesla superchargers use up more power than the supermarket they're usually attached to.
yep.
And man, that's a lot of juice. I mean,
It's a lot. It's a lot, and it's when you look at the Chinese market though, and the way the Chinese grid grows so fast. I mean, they can find the generation for that pretty quickly and put those in there. But it's a ton of power. I mean, trying to think like what was like a megawatt of power. Yeah, it's a thousand units of power. It's a big one moving forward in there. But they actually there's a really good publication out there, basically a Chinese engineering journal that they put articles and research and everything out there for free. And they did a big study on these and said the power demand impact on the grid is not going to be as bad as they thought it was going to be because you charge so fast. Like the coincidence levels are so low that the idea that you'll have three of these full at any given moment, when you're only charging for 5 minutes, it's actually very low. So it goes up, but it's not like a one for one increase. Hey, we put this up here. We just doubled or tripled the power requirement at each one of these stations. They actually said they move people through so fast on them that it's not as bad as they were expecting it to be.
well, my friend with the QST EV chargers that, makes chargers in China, he has one of his chargers has like a 300 kilowatt hour battery in it. Okay.
Yeah.
So it would store energy. So, the information I got says it does include grid storage features. So I'm assuming that you could have the energy for several cars stored up in the batteries
Yep.
in that. And so while you're pulling power from the grid, probably a lot of that 5 minutes would come out of the
Come out
battery.
of the batteries.
And then, like you're saying, it's not going to be running like
Yep.
somebody's not going to be pulling right into that slot right after, especially when it's doing that fast.
When it's going that fast. Yeah.
Yeah. So then that battery's probably recharging. So in reality, instead of needing to pull a continuous 1.3 megawatts, it's probably pulling a fifth of that.
Yeah. Yeah. Well, and when you put multiple of them together, you have power electronics that try to balance that load, and so they're not all pulling demand at the same time. It's a big number. I mean, that's super provocative. Of like, wow, that's a big deal of power transfer. And what comes in my head, things like safety and just the electronics involved in that. It's like that's so much power to absorb quickly, and it's normally the way those things go. Like it's exponential. Just like battery charging, that 20 to 80% range. Great, we can do it fine, but man, to top off that tank, it takes so much more time. And like the parallel is to get just that little bit more power, it takes so much more iron and copper and just electronics in there to be able to handle that much power instantaneously.
Well, maybe it's that fast you won't need to take a bottle of water and
Bottle-
pouring it on the handle while you're charging.
But you just gotta
Yeah,
have better
that's so
timing. You really need to like synchronize it so it works out okay.
I still think about that episode we did on, the ways to make your car charge faster in the hot sun in the summertime.
Dump
Um,
water on the head.
yeah.
Oh boy.
Yeah, it just seems so ridiculous. Um, but this is so much beyond the Tesla supercharger capabilities. I mean, realistically, that would be like quadruple the speed. But
Oh yeah.
but that being said, you still have to have a car that can accept that kind of charge, right?
That's where it is. It's the hardware on the car to be able to handle that much power. I mean, that's a lot of copper, that you need to put on there to dissipate heat, to cool things off, just be able to handle that much. That's the piece that I would be challenged with, especially in a little BYD. Like that's a lot of energy.
But you got to admit that is a pretty cool design. Now, obviously, that would also be really beneficial for a tractor trailer or a
Yeah,
commercial truck taking that kind of size, because those, we already know a lot of those things are going to have 300 kilowatt to 500 kilowatt hour batteries.
yeah.
And so that's far larger, 4 to 8 times the size of your typical car. And, that would still, that would put a lot of juice in there. But I just like the whole idea of how they're storing the energy in a big battery and discharging it out to the car, suddenly, like you're saying, not having music. Because realistically, most people aren't going to come in there and top off 248 miles anyways. They're probably going to be coming in and putting in well, I don't know. It'd be tempting if it's charging that fast.
Like to take it to zero. I mean,
Well, I don't know about taking it, to where it's completely full, but
yeah.
at least to, 80% and moving on, because it's,
Mhm.
best for the life of your battery.
Better for the battery. Yeah.
Yeah, but
I'm with you. I hope that becomes the norm in Nevi stations and all the other bigger stations you put in battery storage with them. You're already doing the work. You're already putting it in there. It helps with the station, and eventually those grid supporting services are what's critical for future expansion. So it's like similar with new solar installations, because the cost of batteries have gone so far down. It's if you put solar on your house today, put a battery in with it if you're able to, just because it's so much more effective.
Yeah. So, a couple days ago, the Neuron, which is an AI newsletter I subscribe to that I really like. If you were going to just have one AI newsletter, the Neuron's a pretty good one. And they don't pay me to say that, okay? But anyways, I like them, and they've started doing some podcasts, and they don't get a whole lot of views on their podcasts, but I watched one. They had the chief science officer of Commonwealth Fusion Systems on there, and he was talking about all the breakthroughs and how they came up with all these ideas. And of course, he's a scientist, right? And he's talking about all these things that they've been successful with their tokamaks and all these things, and trying to make a fusion reaction work. But the Department of Energy has issued a report calling for measurement innovation investment. So investment in measurement innovation. And they're saying that fusion diagnostics, some kind of breakthrough in diagnostics is needed. They're identifying advanced measurement tools as a critical bottleneck for commercial fusion power plants. Now, we've talked about this before, and that like Lawrence Livermore Labs is successfully done. And this was a couple months ago. I had been at a conference where one of their leaders was speaking, and she said that they'd done 10 successful fusion transactions in the previous 3 years, where it produced more energy than it used to create it.
Yeah.
And she said the challenge now is you have to do 10 of those every second, and then to figure out how to shoot a deuterium atom and a tritium atom at each other and hit it with the 70 plus million degrees laser at that
exact moment,
10 times per second, to create that energy needed to sustain a commercial fusion operation. Fusion's super safe in that you're fusing atoms together. You're not splitting atoms. And even when people think of nuclear reactions and you have a nuclear power plant, the danger is a steam explosion from overheated water, right? And the pressure from that overheated water, which you don't have that in the fusion reaction. Okay.
Well, it's not fusion's not self-sustaining. Like you have to put in so much energy up front to keep it going. Whereas the risk with fission is like it gets out of control.
Yeah,
Like
it's creating its own.
you're trying to keep it controlled, but if you lose control over it a little bit, then it just, ping pong balls and chain reactions off of it.
Yeah, the fission is angry. It's trying to create more energy and expand, whereas the fusion just wants to take a break. In fact, one of the things the guy was saying is there's all these things. If you accident and you have to do a fusion reaction in a vacuum because air cools off
Is it too much?
the stuff too fast when you're trying to go from 70 million degrees, a little bit of air getting in the system instantly cools it to the point where it doesn't work.
I believe it. Yeah.
Even the exterior walls, if the temperature was trying to melt the walls, the temperature of the walls causes
That
the
little bit
reaction
difference, it just kills the reaction.
Yeah, I said that all these things that you would just assume would happen, that like it would evaporate everything around it, everything kills the reaction. That fusion just wants to stop.
Mm-hmm.
No matter how hard you try, you have to really keep waking it up.
Because it's something like when they actually successfully do it, it's like the hottest spot in the galaxy, right?
Right.
What they've got, like it's hotter than the core of the sun.
The sun, right? Yeah, for an instant.
An instant, yeah.
But it's constantly trying to snuff itself out,
mm-hmm.
and you have to. And you're basically, it's just like, oh, we're producing energy. We're producing energy. Oh,
Yeah.
It's just, and so the challenge is to kind of keep it going. But so there's this AI-powered plasma prediction. University of Florida researchers using, they call it Hypergator supercomputer with machine learning to predict and prevent catastrophic plasma instabilities in tokamak reactors. 7 priority areas were identified, from low temperature plasma to full fusion power plant designs. Reports call for calibration net US national network modeled after LaserNet US. Now, there's a couple things, and and the guy, they interviewed this guy for an hour from Commonwealth Fusion.
Mm-hmm.
Never once talked, and this was the whole thing when I did this thing in California at this event. The couple people they had from there's like 95 fusion nuclear companies around the world trying to work on.
Okay, around the world. Okay.
Yeah,
I thought you were going to say the U.S. is like, wow, that's a big number.
Yeah, there are lots of countries. We're talking. A bunch of those are in China,
Russia, India, I'm sure, Russia.
France. Lots of people are trying to do this, but the thing they never really bring up is that at any given time on the planet, there may be as much as 20 kilograms of tritium in existence. Okay. Now, when you do a fusion reaction, you're using the 70 to 100 million degree temperature to fuse a deuterium atom and a tritium atom together. And that's what creates the energy. Well, there's not enough. So all of the tritium reactor, I'm sorry, not tritium, the fusion reactions I've seen, they're actually trying to go in the 50 megawatt space. And one of the reasons is there's no fuel to support a larger, like a gigawatt one. So we keep hearing how fusion is going to replace all of the fission nuclear. Well, the problem is, and this is something Mike and I were talking a little bit before the show, it's a circular economy, in that you can't create fusion fuel. It comes from fission reactors. And so typically, so in Canada, there's 19 of what are called CANDU reactors. It's a light water reactor that creates tritium as a byproduct. And those 19 reactors across Canada produce a total of 2 kilograms per year of tritium. Okay. Now, a 1 gigawatt, which would be the size of, like, when people think of nuclear, they think of like a cooling tower.
Yep.
Okay. And a cooling tower typically represents a gigawatt of energy, which is 1,000 megawatts. Okay. Now, the challenge here is one of those gigawatt reactors would need at least a minimum of 100 kilograms of tritium annually to power that thing.
Power it.
Okay. Now, like I said, there's only 20 kilograms in existence. Okay, on the planet. Okay, and all these 95 companies have to share this. Okay, there's a huge bottleneck there. Now there are ways to make it, but those can-do reactors aren't extremely.
That's not going to make it. No, I mean we can do that math in our heads.
Now,
that's not
to make tritium, and I don't know the whole process. You need something called lithium-6 to be able to make tritium. So it's a crucial supply chain element in that. Also, there's another, in the making of lithium-6, you have something else called lithium-7. The two are made in the same process. Lithium-7 is needed to make a molten salt Gen 4 reactor. Okay, because I hear people all the time, talk about, different ideas in the space and how to do cooling and all that. Well, only 2 countries in the world currently produce lithium-6 and 7. That's Russia and China. As a result,
best friends out there.
Yes. As a result of all the sanctions on Russia, Russia said, we're not exporting anymore lithium-6 and 7. You guys can all go screw yourselves. Okay. It's ours and we're not sharing it. And China pretty much won't share it either. So a whole lot of companies in the molten salt reactor space, we hear of molten salt stuff coming out of China, right?
Yeah, it comes up a lot.
The reason we're not hearing it coming out of anywhere else is because nobody else can do it. Yeah. So all of these, I'm a big fan of fusion. I think it sounds awesome, but there's going to be some real challenges in the supply chain, and it's going to require a whole lot of fission nuclear that's set up to produce the tritium needed for that cheap fusion energy. Because the thought is fusion may be able to be produced for like 1.5 to 2 cents a kilowatt hour as their levelized cost of energy.
Yeah.
But not if they don't have tritium.
Not if they don't have to
turn it on. Yeah, because we hear all this all the time. It's like, nuclear runs forever. It's free power or whatever. It's like, yeah, there's all these things.
Not really. And it's good sleuthing work there, David, of like peeling back the layers of finding lithium. Not even exotic. I wouldn't even call it that, but I'm sure that isotope.
Lithium's not exotic, right?
Yeah, but the weird 6 and 7 isotope, that's very exotic, and it's only 2 people in the world make it, and they're not going to give anybody any. So that's very fun. It's not funny, but I mean, it's weird how that stuff plays out sometimes.
Well, you think about it, because we're constantly talking about clean energy, and in my mind, there's fusion's super clean. Okay, one of the things that you get as a byproduct from fusion is I believe it helps create helium.
Yeah.
And so when we're talking about making high temperature gas reactors that require helium, we can get helium from the fusion reactor. So it's really quite interesting how they're so synergistic.
Yeah.
But, cool. As nuclear becomes so much safer, I was telling, somebody was talking about the rate of incidents of people getting injured producing nuclear energy over the years, and we're counting the deaths at Chernobyl were the main one. Okay, but there's been other things. People falling off ladders.
It's a dangerous environment. Yeah. There's moving parts. Yeah,
it was 0.03% of a person per. What was it? It was a bigger number than gigawatts. What would be
bigger?
Terawatts?
Tera?
Yeah, it was something like, they were like per terawatt of power. It was like 18 people have died from producing petroleum. Okay. And it got even worse for coal. It was like 24 people.
Oh, really?
Per terawatt of power from coal.
Because it's such a dangerous to get that extraction.
But from nuclear, it was like 1/30th of a person per terawatt. Okay. So you had to have 30 terawatts, whereas like for oil and gas, it would have been 540 people for the same amount. Okay. It was huge. And I was like, have you guys ever looked at all the deaths from hydroelectric? Hydroelectric's the big killer because one dam broke and killed
Killed
175,000
a bunch
people.
of people, and yeah,
Yeah.
yeah, that's
Yeah. So it's really, people think about nuclear as being so dangerous. It's like, well, not really.
no. I mean, we've got a handful of incidents in 50 years, and plus it's the challenge of nuclear today. It's so regulated from a safety standpoint and what you have to do. And having I never worked at a nuclear power plant, but worked with a nuclear power plant and worked with a lot of people who worked at a nuclear power plant. And the safety and the steps and everything associated with it's mind-boggling. And it's why it's so safe, or why the old Gen 2s and Gen 3s were so safe, just because they had the crap engineered out of them and had the staff to monitor it and fix it and take care of it all the time.
Well, it's funny, we talk about, people are always talking about how in the supply chain of EVs, like, oh, the cobalt, it all comes from, children mining cobalt in the Congo or whatever. And, it's like, well, not really. When we use LFP batteries, which are becoming the most common right now, that doesn't use cobalt. Okay, but the older batteries,
the older ones, yeah,
the ones in your cell phones, they use cobalt. Okay, so don't cry about the child slave labor in an EV if you're using an iPhone.
Yeah.
Okay, and but we have these issues, and there's certainly no shortage of complaints and legitimate complaints about the lack of rare earth minerals.
Oh yeah,
that are refined in China because they're the only people who will do it. Nobody else wants to refine those rare earth minerals because apparently it's toxic and polluting.
Just the higher the atomic number, the more toxic you get.
Right.
Just as a general rule of thumb.
Yeah. As I was looking at the manufacturing of tritium, I can't remember what exactly it said, but one of the things was you have to use like poisonous dioxide or dioxide poison something. It's like has poison in the name.
It's just in the name.
In the name. And I can't remember exactly what it was, but it's like, oh, that's kind of scary.
That's what they're not even trying to find out.
We know we're not going to be handling, uranium and the tritium in our hands or whatever like that. But just having the word poison in the title, like, oh, that might be
let's keep an eye on that one. Put the childproof lid on that one.
Yeah, I had never seen the word poison used in a technical name before. At least not in the energy space, right? Yeah. But I just find some of this quite fascinating because we look at all these solutions for energy, and I tell people, it's like, look, I'm all about clean energy, but it so much just keep pointing at LNG as being the real solution to everybody's problems, and that's how people are solving the data center problems right now.
That's how it's happening right now. Yep.
Yeah, I mean, LNG is hot. In fact, one of the criticisms I'm seeing is the equipment's gotten so expensive, the LCOEs have like quadrupled.
Just because the equipment costs?
Just because of the equipment costs. Yeah. And but it's gone from like 3 cents a kilowatt to 12 cents a kilowatt. And the problem is these data centers have to have the power. They've got no business without the power. They've got to pay it.
Yeah.
And what it's doing, though, it's hurting everybody else because it means that, if your grid systems needs to upgrade its burners for the LNG, they've got to pay more. And that's why here in Omaha, we can't shut down our coal plant.
Yeah, there's a lot of proposed changes coming into the industry in that space, and basically it's, if you were going to come with that high of a load, you pay for 100% of whatever upgrades you have to bring to it, where it's like we're not going to bake this into the formulas anymore, because there's a lot of that where like rates, your tariffs, what you pay every year for your power bill, that gets reviewed all the time and updated, and it incorporates the cost of energy and the cost of the supporting infrastructure in it. So those change a lot, but it's what they're starting to say is with these big, 500 megawatt, gigawatt size data centers, like we are taking you out of the equation. You are going to pay 100% of that cost. Like we're not going to go take a risk on this or do anything. Like it's you're writing us a check up front.
Yeah, it makes sense. It makes sense.
Yeah.
I
Yeah.
still, when I tell people about that 8 gigawatt project down in Texas,
Mm-hmm.
I'm like, hey, that could power Houston. It could power. It would be in the top 5 U.S. cities, probably. Just that one data center in Texas that's completely off grid, mostly burning. 90% of it's going to come from LNG.
Yeah.
And
Well, we're out in Nebraska, and in the city of Omaha, we've got less than a square mile that consumes more power than a community of a couple 100,000 people. I mean, it's a tiny little space where we have Google and Facebook, and it consumes more power than our capital city of Lincoln. Just in that tiny little footprint, it's unbelievable, staggering numbers. If you worked in this industry before.
and the funny thing is, they located here when they could get power for like 7 cents a kilowatt.
Yeah, we courted them. The local community and power company gave them a sweetheart deal where it's basically you can play the markets and go out secure your own power contracts, and we'll just give you the infrastructure. And now that's everybody. When the largest companies in the world are all lined up out the door and like we want in on this, you start to wonder like, what
What do
did we
they
do
know?
something right here?
Yeah, I
was
mean,
it the right?
they really knew. I mean, I look at what the hyperscalers are all doing in the nuclear space, reopening 3 Mile Island and, some other things. And it's fascinating to see where all of them have invested something in nuclear, or at least, like Sam Altman's been on the board. He was the lead investor, or probably still is the lead investor for Oklo.
Mhm.
And you've got Microsoft's been in a couple of these. I think they're the 3 Mile Island one.
Yeah,
Yeah, and it's just unbelievable what's coming down the road.
Mhm.
All right, well, let's shift gears over to robots. All right, so Tesla Optimus Gen 3 robot reveal. So they revealed the Gen 3 robot, and it's had a big impact on their stock. They're set to unveil.
That's the one where he said we're going to have in whatever 50 million of these out by 2032 or something like that. What if his staggering numbers?
Yeah, it's going to be more than they're selling cars.
Yeah.
Yeah. Let me see. They're set to unveil the Optimus 3 this quarter, emphasizing improved dexterity and manufacturability for factory deployment. And hopefully it won't be just a bunch of people somewhere operating them.
Yeah, with a remote control.
Yeah. But Musk's big bet on robotics comes with significant risks. Success far from guaranteed despite massive growth opportunity claims. The stock valuation is becoming increasingly dependent on robotics and robotaxi promises beyond the core auto business. Well, that's what Musk has always said.
That's what they've aimed for, right? I mean, that shouldn't be a surprise.
Yeah. The funny thing is, Tesla stock's down 11% year to date. For 26, but where are we at today? I haven't looked at our stock ticker today. Here we come. Tesla's coming around. 403. Oh, it's up almost 3% today. It had dipped into the 390s yesterday. Rivian, it was up to $22 back, a month or so ago, and it's kind of settled back down.
Did they spike after the R2 announcement?
It did a little
bit,
and then just sort of fizzles back. But the thing going on in Iran has really rocked the stock markets.
Yeah.
It's nice to see things back in the green today, but a lot of this is just kind of rebounding. It's like, okay, now the Iran thing is just kind of a normal thing.
It's a little bit more known and stabilizing.
It's just like one of my friends launched a crypto token the same day that Russia invaded Ukraine, and it didn't go well for the coin.
Yeah.
Man, NewScale looks like a bargain at $12.77. Some of these, Oklo at 65. It reached 193 a few months ago. And so some of these just look like super deals in the space. I think it's really hard to ever argue against Tesla, but Tesla got to almost 470, I think, at the end of last year. So it slid back down. But we've seen a lot of that. Let me see. Oh, let's move on. And let's see here. We talked about BYD. You know, sometimes I get all these articles. All right. So it's official. Canada's China EV quota went live March 1st.
All right.
First 24,500 permits are first come, first served. So Canada's agreed to significantly reduce tariffs on Chinese EVs, allowing up to 49,000 to be imported on a first come, first served basis over the next year. It drops the tariff to 6.1% from 106.1%. It was a full 100% decrease it imposed in 24. They can be imported into Canada from March 1st to August 31st. And
So
then,
do you know, is this like individual sales, or is China setting up any dealerships out there?
well, you know, one of the things I heard was what's expected is it mostly that their Tesla is going to bring Teslas that they make in China
that they're going to
and,
take up a
and
big
sell
chunk.
them in Canada.
Okay.
But by 2030, Canada is going to allow, we're going to keep ramping the number up to 70,000, including all electric, hybrid, and plug-in hybrid models. There may be some limitations in the first 6 months. They'll monitor the application issuance of import permits for the purpose of providing equitable access to a quota of to eligible applicants. You can look to countries like Australia to see what type of Chinese EVs will import into Canada. I'm sure whatever vehicles end up in the Great White North will taunt Americans who are waiting another year for Ford's $40,000 EV lineup. Man, you know,
Ouch.
I mean, think about it. If all of a sudden, I mean, if you were a Canadian and you wanted to, what is it? Was it the Seagull that's so cheap, or the Dolphin?
Seagull. Yeah.
Yeah.
The Dolphin's dirt cheap. Yeah.
Yeah. You know, you start bringing over some $10,000, bring over the BYD Shark, you know, that'd be a cheap electric truck. But Volvo and Polestar are assessing the situation with nothing concrete. But right now, the most likely ones are going to be Tesla, Volvo, because they were already importing EVs to Canada from China before the tariffs were implemented.
I was just gonna, their supply chain's in place. They're ready to go.
Chinese company Chery is considering opening a plant in Canada and manufacturing. Recruiters for Chery contacted Canadians in the automotive industry on LinkedIn, asking if they'd be interested in upcoming roles for the expansion. And they have an innovative concept that's a diesel plug-in hybrid.
A diesel plug-in hybrid.
Yeah, who knows?
Oh, I haven't heard of that before, to be honest.
Let's see. Chinese automakers Neo, Xpeng, GAC Group, and Li Auto don't seem interested yet. Of course, you know, the truth is Canada is about the size of California, right?
Yeah, it's not a giant.
It's only like 30 million people or something like that. Australia is about the same size.
Mm-hmm.
So I don't know how large.
You'd feel like if you were those manufacturers, you'd want to get a better foothold in Mexico, in Central America, you know, with bigger populations, more sales percentage if you wanted to get yourself into North America.
Let's see here. All right. Tesla buys Chinese cars and dismantles them to see how they're building them. Now, this isn't necessarily anything new. I mean,
I got to admit, well, I mean, Ford did that last year, right? I mean, they went there and took them all apart.
Yeah. Let's see. During an interview with Business Insider, John McNeil, who served as the president of Tesla from 2015 to 2018, gave some details about where the Chinese EVs had taught Tesla. And the Chinese engineers are really disciplined about reusing parts underneath the hood that the customer can't see, and they save a lot of money that way. I don't know what that means.
I don't know what that means.
Parts. BYD in particular said the cars use the same windshield wiper motor and heat pumps across all models.
Okay. Okay.
Okay, so
Yeah,
first I was thinking, was it used?
it's not they're going to like you pull it and
Yeah, I was like, are you using used parts? So when they built the Model Y and the Model 3, they used around 75% of the same parts, including powertrains, door handles, and buttons. This lowered manufacturing costs.
yeah, I mean that's just good business. I mean that's
Yeah, as opposed to making one for each model, they simply made the models use what was existing, which maybe that's a different look. Wow. Ford's CEO had declared that Ford had no future if it couldn't compete with the cars coming out of China. Well, I saw some stuff yesterday was talking about, maybe the U.S. auto manufacturers end up only making full-size pickups and SUVs just for the U.S. market. That's kind of what it's starting to look like, right?
Yeah.
It just seems so weird when you tell people that there's an EV Ford Explorer in Europe, and people are like, what? Why would they do that?
That's wild.
Just the nature of things. But that's where that's sitting at. But the whole Canadian deal, opening up that space, it is just, you just wonder what this is going to mean for the US, because we're going to start seeing these cars more and more as Canadians come on vacation.
Well, especially a year or two down the road, once you've had all of those vehicles on the road over there, I think it's going to pop up more and more.
Let's see. Good. All right. So a US company called Electros Inc., which is on the OTC as stock ELEK, just announced with the US Patent and Trademark Office a patent for a multi-port charging architecture designed to aggregate multiple high-power inputs into a single vehicle interface. The tech aims to hit a long-term objective of a 7-minute full recharge, effectively matching the time it takes to fill a tank of gas. So I think what this matters is, and I've talked about this before, when you're filling a tractor trailer with fuel, you pull in and you have
both sides.
Yeah, you're hitting both sides. Like, why aren't they doing this with batteries?
Yep.
Or my thought was maybe you could have two separate batteries in the car.
Yeah, just two completely different packs.
Charging. And this one is trying to make this work. So this Electros company is addressing the structural limitations of current single port systems. It's not just about a faster charger, about a vehicle architecture that can swallow that much power at once.
Cool.
We were just talking about
that.
We were
just talking about that.
Megawatt thing. Yeah. It's like, well, I'm not aware of any cars that can take that kind of juice yet, but you just don't know. And I thought that was, that seemed like kind of a cool thing.
Well, what's cool about it is at this stage, it's the visual you have in your head of the multiple plugs coming in. It's still going to be just one plug. It's just going to be, here's two extra wires, here's two extra wires. And then the architecture in the car, it's going to work that way. So it's cool to see innovation like that of people coming up that way.
So BYD, one of their subsidiaries, is a luxury brand called Denza. And they previewed an updated Z9 GT today, claiming it's the world's longest range EV. It has a range of 1,036 kilometers, which is 644 miles. Okay. Now, this is based on China's optimistic testing cycles. Analysts suggest that under US EPA standards, this might drop to 450 to 470. Because right now, the highest US estimate is for the Lucid Air Grand Touring, which is 512 miles. Okay, actually means it really remains the range king, at least in the Western market. But that Lucid Air Grand Touring, I think, is $200,000. Okay, the luxury gap here is the Denza starts at 51.5.
That's their luxury model.
Yeah.
How do you spell that?
Range American competitors.
Is it Denza?
Yeah, the Denza Z9 GT. Let's see. Z9.
Those aren't bad looking cars.
Let's see.
They look a lot like a Tesla.
Yeah, well, let me We'll pull this up on the screen.
That one looks kind of like a Porsche.
Yeah. Yeah, they made claims about it being the fastest luxury electric vehicle. There's been, other things they've claimed, but it looks like Mercedes has something to do with this brand too.
I know. I'm looking at this too. I saw Mercedes pop up a couple of times.
Yeah, I mean it's sharp looking.
Yeah, they're not bad looking cars.
Yeah,
I'm sure the inside's nice. I mean, I'm sure it's a nice vehicle.
Let's see. I kind of like this color here. Oh, it didn't pop up. Sometimes stuff mixes well, sometimes it doesn't. Anyway, yeah, that's just that's really something that it could have that kind of cars starting to have these kind of ranges. We had a case where somebody drove a Chevy truck like 700 miles on a charge, but they drove it at like 20 miles per hour or something like that.
Crawled along with wind downhill.
And just to make sure that it maximized the battery or whatever. So we know that there's some things with that. Okay. A NASDAQ company called Beam Global, which is spelled BEEM is the ticker, but it's BEAM is the name of the company, but BEEM is the ticker, deployed a solar-powered EV ARC system in Michigan today. And they did it in Michigan. It's a direct response to recent multi-day neighborhood power outages. These units are 100% off-grid and continue to work even when the local utility fails. It's targeting a gas spike angle. They're marketing this as a hedge against energy volatility, citing a recent 11-cent overnight jump in local gas prices and the $150 billion cost of U.S. power outages. It's funny. It's like U.S. doesn't have a lot of power outages.
We're pretty good. We're pretty good.
$150 billion annual cost of power outages is a massive number. But these solar systems are held in place by gravity and can be deployed in as little as 4 minutes without any construction or trenching. So this must be,
does it say?
This must be something larger, maybe for emergencies. Yeah. It was designed for off-grid resilience. Let's see. So an organization called the Business and Human Rights Center, this sounds ominous, is talking about the dark side of supply chain ethics. Released a report today finding a disproportionate link between green energy incentives and labor abuses. I mentioned earlier the thing about, if you have a cell phone, you're using Cobalt, which comes from the Congo, and there's a couple of kids there that, they can either starve or they can work. Okay. And they choose to let them work. I mean, you take your pick, either let them starve to death or complain about slave labor. Okay. Or child labor. 19% of abuse cases in the green sector were linked to excessive production targets compared to only 7% in other industries. The report warns that the rush to meet 2030 decarbonization goals is leading companies to prioritize speed over worker safety in both EV assembly and mineral mining. And it's specifically nickel and cobalt.
That's unregulated capitalism, prioritizing production targets.
Yeah,
that's over safety. That's what we're built on.
Yeah. It's funny. It's like, I'm all for not having child labor making stuff. It's like, but on the flip side, you got to remember, maybe those kids starve to death if they, we don't know their situation, right? There's two sides to every story. It's like, you're just assuming those kids don't want to work. I mean, in an ideal world, they wouldn't, right? But unfortunately, nothing is ever ideal. And it's just like in politics, everything that the politicians put together, there's always something wrong with it that nobody really paid attention to, or nobody thought was a real problem.
Was actually somebody was going to complain about it.
Yeah. I mean, it's like, you know, everything the government does seems to be that way. There's, you give it to somebody that maybe you should have been given to someone else. You're taking from some other program. You just never know. But yeah, but I thought that was like, that's kind of ominous. It's like, oh yeah, that's green energy. Is it bad for the workers? Right.
Yeah.
So anyways, I love some of that. It's like, well, I'm not going to say I disagree with you. Maybe there's some truth to that, but because certainly some of it's rushed. But when we were talking about those numbers of like workers who die, producing coal, and that's a big number of deaths per terawatt of power.
Oh, it's dangerous. I
Yeah.
mean, it's all that stuff. It's real.
Yeah.
It's just that most of our coal's mined in the U.S.
Yeah, and I figure with geothermal, the danger is probably, once again, it goes back to lava. How many people die from lava, in the geothermal industry, which may not be a whole lot, but I'm just saying. Anyways, well, Mike, that's everything I had to cover today. Thanks for doing the show today, folks. Thanks for watching. I'll be back on Friday with Bill, and hopefully there'll be some interesting and wild EV news to report. That'll be more interesting than the war in Iran. So
EVs are pretty unexciting right now, to be honest.
Right. Yeah. Anyways. All right. See you later.